So we are going to use the Gauss-Jordan elimination in order for us to solve for this given linear system. If you have noticed, this is a familiar linear system, for we already tried solving for this in a separate video using the Gaussian elimination. In that video, we were able to achieve or reach a row echelon form, which helped us in solving for the unknowns, x sub 1, x sub 2, and then x sub 3. Now, we are going to use the Gauss-Jordan elimination or move further to the reduced row echelon form of this linear system. But since we already have, again, the row echelon form of the previous video, let us try to use for that here, so that this would be a little bit shorter. I'm just not going to come up with the augmented matrix for this, but the equivalent row echelon form. And if you are confused with that, there's a separate video for this in our channel. You might want to look into it as well. In the previous video, as mentioned, after coming up with the row echelon form, it is actually 1, 1, 1, 0, 0, 1, 4 sevenths, 1 7, and then the third row is 0, 0, 0, and 0. Notice here that one of our row is all zeros, and this would mean that there was a out of the three variables here, one of which is represented by an arbitrary variable t, and that was actually x sub 3, and we used that to represent x sub 1 and x sub 2, and we have decided on that video that there are infinitely many solutions here. Okay, so I'm just going to write it here. X sub 1 during that time was negative 1/7 minus 3/7 t. Our x sub 2 during that time was positive 1/7 and then minus 4/7 t, and the x sub 3 is our variable, arbitrary variable t. The reason of presenting this is that even these are answers using Gaussian elimination. If we are going to use the Gauss-Jordan elimination, we should return to the same results. Okay? If we will not have the same result, there are two indications for that. Number one, our Gaussian elimination previously was incorrect, or whatever we do here today, or this video for our Gauss-Jordan elimination will also be incorrect. So let's show it that, let's show from this, that from this row echelon form, and then we use, we go to the backward phase of the Gaussian elimination of the second half of it and come up with a reduced row echelon form. Let's see if we have the same results. We only have one task here. We need to make this 0, because for a reduced row echelon form, and as comparison to the row echelon form, there's only one additional concern, and that concern is that for the same column containing a leading 1, all other entries must be 0. So we're going to make this 0 here as mentioned. So we will apply this operation. We will multiply negative 1 to our row number 2 and add it to row number 1 to have a new row number 1. And that would mean it would look like this. The third row are all still zeros. Second row was not touched. The first row would be this. Negative 1 times 0 is negative 1. Negative 1 times 0 is 0 plus 1, 1. Negative 1 times 1 is negative 1 plus 1, 0. And then we have achieved that. But we are not yet done. Negative 1 times 4/7 is negative 4/7 plus 1 is positive 3/7. Negative 1 times 1/7 is negative 1/7 plus 0. We have negative 1/7. This is now our reduced row echelon form. Again, pardon if this is a little bit shorter because we have already secured the forward phase or the Gaussian elimination for this. Again, check that video for that, so that this video will not be very long. So we have this now, and then we are going to come up with the equations that represents to this augmented matrix. So we have x sub 1 plus 0 x sub 2, so that's 0, plus 3/7 x sub 3 is equal to negative 1/7. The next is x sub 2 plus 4/7 of x sub 3 is equal to 1/7. And see here, that there's no exact value for x sub 2 nor x sub 3 nor x sub 1. So we are going to represent one of them as an arbitrary variable. And we chose here, just like last time, so we choose here x sub 3 as our t, so that we will have the same variable here. And with that, this equation here would become x sub 2 plus 4/7 of t is equal to 1/7. That would mean x sub 2 is equal to 1/7 minus 4/7 of t. Okay, this is the result. Is this the same as this? Yes, right? So this is the answer last time from the previous video using Gaussian elimination. It is the answer in completing the reduced raw echelon form using the second phase of Gaussian elimination. We have achieved the same result. Let us see if we have the same result for x sub 1. X sub 1 plus 3/7 of x sub 3, which is t, is equal to negative 1/7. So x sub 1 is negative 1/7 minus 3/7 of t, the same value here. So see, whether it's Gaussian elimination or Gaussian elimination, with the same linear system, we have the same results. But then again, here we have infinitely many solutions for our one of our variable x sub 3 specifically is t, and t can be any with any values. So this is now the solution for this linear system using the second phase of Gaussian elimination, achieving a reduced raw echelon form, which is similar to the result for the Gaussian elimination in the separate video. Thank you for watching.